So first, I just want to take a look at our Canvas course real quick and review a couple things to get us started. So I will share my screen. Like that. And I've already got it in the student view so you guys can see what it looks like for you. So again, keep in mind in the course that the daily things that we do, such as activities, presentations, things like that, will be put into the calendar. The live class recordings, right? That's where we will find these things. So if you wanted to look at yesterday's lesson, the recordings will be in here on the 19th. Right, period 1, 3, and 5. Right, and it's organized by class period because each class gets a slightly different varied presentation, mostly the same. Every once in a while there's different questions asked, and so on. All right, there we go. So I post all of it. You're welcome to look at other class periods, class recordings, see if they got something different that you missed. I don't know, it's up to you. But yeah, it will be available. I don't limit the availability of these things. You'll see we have today's activity. The recordings I haven't quite finished yet because they required more editing today than normal. For today, for the previous class periods, those are underway. So yeah, that's where we find our day-to-day things. The modules more house the things that are for the entire chapter and sections. All right, so if we look at our modules here, like chapter 6, we have the notes and resources, practice problems and solutions. Then I added the Pear Deck that we did last week for section 6.1. All right, so there's a link to the Pear Deck, and this is actually the assignment that I gave you guys a grade for doing, for being there, participating in that Pear Deck. You were given a grade of complete or incomplete if you didn't do it. And I also have the solutions here. So if you're curious as to the solutions to some of these problems, they are provided. I'll do something similar for section 6.2 with the activity that we're going to do today. Today we're doing a Desmos activity because I like to mix things up and try things, see which ones work best. That'll be added in with our 6.2 stuff. All right, I've started working and putting together chapter 7. However, if you notice, right, in the student view, this is not available yet, right? It's all grayed out. It's here, but you can't click into it. All right, there's a prerequisite, chapter 6. You need to submit the assessments for chapter 6 before chapter 7 opens. All right, I want you to be able to move through the content at your own pace, but I also want you to go through it in order because things build on each other. So if you haven't finished chapter 6, right, then you shouldn't be moving into chapter 7 yet. I'll open up chapter 7 to everyone once we get there as a class. But if you're trying to move ahead, finish chapter 6 first, right? So there's that. Lastly, I did this last time too. I don't want to look at it in the small view here. I'm going to go to the actual module view. So I get a full page view. If we look at the free response question assessment / self-assessment, this is in the form of an assignment. All right, you have unlimited attempts, just like last semester. The details, which includes section 1, which is the free response questions. There's 2 questions, obviously they have multiple parts. Listed here, and then section 2 is the self-assessment and reflection. Right, you self-assess, answer the reflection question, right, and then you'll be able to submit. Right, you have multiple submission types to choose from. You can just do a simple text entry, start your entry. If you are sharing a document, right, like you're sharing the link to like a Google document or something like that, you can do that here, I believe. I don't know what more options does. You can record yourself answering the questions if you so choose to, or you can upload a file. You can do any sort of file type you like, a document, PDF, what have you. If you are uploading a file, remember it only accepts 1 file. So if you're taking pictures of your work that you did on paper, which is absolutely fine, make sure that you actually use a document scanning app on your phone and not just take pictures, right? Because it won't allow you to upload 4 or 5 different pictures if you need multiple pages, right? You can only do one file. If you use a document scanning app, which there's lots of free ones, it will compile those pictures into a single file, which is what we need, one file, right? If you need help with that, please let me know. I'm more than happy to help. But yeah, so there's multiple submission formats here for you to choose from. Choose whichever one you think will work best for you. Yeah, so keep in mind with the text entry, right, you get your full set of like tools when you do the text entry, so you can add in pictures and links and things like that if you're using the text entry, right? You have all those options. Great. Any questions about this? Because this is slightly different than how we did it last semester. Okay, excellent. Then we will move on to the activity for today, which is a Desmos activity. All right, the other thing that I've done in Desmos is I've actually created classrooms in Desmos. Now, the fun thing is you don't have to do anything special. I'm going to put a link in the chat, which will give you the link to our activity and also add you to the class in one single foul swoop. All right, so I'm going to copy this link. We're going to put it in the chat like that. Should be there. All right. And please click that link. You'll be able to join into the activity and also be added to the class, which then gives you access in Desmos to any of the activities that we do in class. If I make a Desmos activity, it'll be added to the class. You'll be able to access it just by going to student.desmos.com. All right. This is going to go in kind of like 2 parts today. We're going to do the first part of this activity, basically the first 5 screens as a whole class. Okay, I'll kind of pace the activity. We'll work our way through the questions. Then the last 3 slides here, you guys will end up doing on your own in some breakout rooms. You'll not be given enough time to complete all 3 questions when you're in the breakout rooms. So the idea will be that you will review the questions, see if you have an idea of how to solve them, talk to the people in your group about how you could solve them, and then answer the ones that you have time to. We'll come back as a whole class at the very end, answer any questions, and then we'll be on our way. So that's the general idea for today. All right, so if you're one of the 2 people who have chosen not to log into Desmos, there's people making noise out here. Well, you're choosing not to get points for today, and that's sad. All right, so we're going to get started. Yeah, seems like we're at a good spot. Let's do that. There. Excellent. If you have questions, please remember, put them in the chat or unmute your mic and let me know. All right, we are going to move. Yep. To the main screen here. Give it this view. All right, so as we begin here, remember the following from yesterday's lesson. Adding or subtracting a constant a to a random variable increases or decreases the mean of the random variable by a, but does not affect its standard deviation or the shape. I'm specifically talking about mean and standard deviation because those are the 2 values we're going to be dealing with today. So we're not bringing in things we're not talking about today. If you are multiplying or dividing a random variable by a positive constant b, right, multiplies or divides the mean of the random variable by b and the standard deviation by b, but does not change the shape. All right. If you have a linear transformation of a random variable, meaning you are adding, subtracting a constant a and multiplying, dividing by a constant b, or one or both, then you can write the linear transformation of the random variable x in the form of y equals a plus bx. All right, and I lost people already. That's a bummer. So that's just a quick review of the things you will need to keep in mind as we work today. So with that, we're going to move to the first question. Boom. Now everyone should be able to move over. So, question number 1 here about men's heights. A report of the National Center for Health and Statistics says that the height of a 20-year-old man chosen at random is a random variable h, with mean 5.8 feet and standard deviation 0.24 feet. You're going to find the mean and standard deviation of the height j of a randomly selected 20-year-old man in inches. So we're transforming height in feet to height in inches. All right. So we have height j in inches. There are 12 inches in a foot, just as a reminder. So you'll do the transformation. All right. Convert from feet to inches. You will type in whatever number that ends up being. Right. You'll hit submit, and then the next entry box shows up. It says explain your thinking. Right. Do not try to type your explanation in with the numerical entry area. It just doesn't come out well. It doesn't type friendly. All right. So I'm going to give you all just a couple minutes to work on this first problem, then we will discuss. All right. And if you have questions, let me know. All right. So for this first problem, the transformation that's occurring is we're multiplying by 12. Right, to go from feet to inches, you multiply by 12. All right. So that's the transformation. It's multiplication, which means the transformation applies to both the mean and the standard deviation. All right. When we do this calculation, we'll end up with a mean of 69.6 inches, right? And a standard deviation of 2.88 inches. Right? And again, this is a multiplication transformation, so it applies to both the mean and standard deviation of the variable that's being transformed, which was h, and it turned into the random variable j. Is there any questions so far? So then we're going to move to the next question. The next question is broken into 3 parts. We're going to do it a little bit at a time. Right? So for this problem, we have Anna. She's a dedicated skee-ball player, right? If you're not entirely sure, remember what skee-ball is. It's the game like fun centers and stuff where you roll the ball up the little ramp, try to get it into the little holes for different amounts of points, right? And Anna always rolls for the 50-point slot. Probability distribution of Anna's score X on a single roll of the ball is shown below. You can check that the mean is 23.8 and the standard deviation is 12.63. Right? And this is our distribution table. Right? A player receives 1 ticket from the game for every 10 points scored. We're going to make a graph of the probability distribution for the random variable t equaling the number of tickets Anna gets on a randomly selected throw, and then describe the shape. I forgot a text entry spot for this one, so in describing, think about how you would describe it. All right. I suggest to draw on this using the line tool. It's the second tool in from the left. You can change the color if you want. And draw your boxes using this tool. So for instance, the first bar for the histogram is going to be for 1, which 1 is kind of in the middle between 0 and 2. So I'll draw a line up to about where I think 0.32 is. Go over and down. If it's perfect, doesn't matter. Probably won't be perfect. That's fine. All right, but this would be the first bar, and then continue building your bars from there. All right, so again, I'm going to give you all a few minutes to draw your histograms. Remember, these are histograms, so the bars should be touching. All right. Alrighty. So if you guys click back to the shared screen here so you can see what's going on my screen, this is what the histogram should be close to. And I'm going to polish it off my histogram here. Right, it basically should look like a staircase going down from left to right. Your bars hopefully are close to the same width. If they're not, it's okay. We're drawing this by freehand using a mouse or possibly even using a trackpad. It makes it a little tough, and that's okay. We're looking for close and not perfect today. All right, so essentially your histogram should look something like this, and it is skewed to the right because the tail is on the right. And we have a peak at 1. Our center is going to be probably just to the right of 2. All right. And it doesn't appear to have any outliers. So that's a short description. All right. And so this is what our distribution should look like for T, number of tickets. Is there any questions? So now that we know what this looks like, we're going to move on to the next part. All right. In this next question, we have the same context. We're still considering the random variable t for the number of tickets on a randomly selected throw. We're going to complete the probability distribution as a table. And number of tickets can go from 1 to 5. And then you're going to find and interpret the mean of t. All right. And so again, what you'll do is you will type in whatever the answer is, hit submit and explain. On here, on the explanation, I want you to interpret the meaning of the mean in context. So what does it mean? All right. As far as the number of tickets Anna should expect to get on a randomly selected throw over time. All right. So once again, we'll give you all a few minutes here to do this calculation. And then we'll reconvene. Okay, so let's talk about this problem. Now, again, we're dealing with transformations. The transformation going on here from x to t is division. I take the score, divide by 10 to get the number of tickets. All right, so we can use that transformation to easily or more easily calculate the mean. Right, the mean of t is equal to, let's see if I can get this to do what I want it to do here. Right, the mean of t is equal to the mean of x divided by 10, which equals 23.8 divided by 10, which then equals 2.38. Right? You will get the same result if you do this the long way and multiply the number of tickets by the probability of getting that number of tickets. So 1 times 0.32 plus 2 times 0.27 plus 3 times 0.19 plus 4 times 0.15 plus 5 plus 0.07, you'll get to the same number. All right. Any questions on how we got here? Again, we get 2.38 tickets, and in context, what that means is that over the course of many rolls, right, Anna will average about 2.38 tickets per roll. Right? All right. So here we go. We're going to progress to the last part of the skee ball question. Same context, same two random variables, x and t. Now we're finding and interpreting sigma t, which is the standard deviation of t. Again, keep in mind that we're doing a transformation of dividing. All right, remember what dividing does to the standard deviation. You can have a shortcut to the answer. All right, so we'll give you all a couple minutes here to determine the standard deviation. All right, so then for this problem, right, the standard deviation of t is equal to standard deviation of x divided by 10. Since we are dealing with division, division affects standard deviation. Right, that's the type of transformation that does. Right, and we end up with 1.263 tickets. Right, so that means that on average, the amount of tickets Anna receives on a randomly selected throw or a randomly selected roll of her ball will vary from the mean of 2.38 by about 1.263 tickets. Right. So again, we're using what we know about linear transformations now so that we don't have to do all the intense calculations. We can divide a number we already have by 10. All right. What questions does anyone have so far? All right, Valentine, have a good day.
Have a good day, guys.
All right. Excuse me.
I have a question.
Yes.
Okay, so I don't know if I'm the only one. I'm pretty sure I might be the only one. But how do you know if you're dividing or multiplying? Because I'm kind of confused a little bit.
All right. So, like with this problem, right? It never directly says we're dividing by 10, right? However, we're told that you get 1 ticket for every 10 points scored. Right, so that means we take the number of points scored, divide it by 10, that gives us the number of tickets. Right, so it's inferred through the context in this case that we're dividing because we're going from points to tickets. Right, on the first example with men's heights, we had implied multiplication because we're going from feet to inches. Right, and we have to go from feet to inches, we have to multiply by 12 because each foot is 12 inches. So it's typically not going to be directly told whether you're multiplying, dividing, adding, or subtracting, but it will be kind of inferred through the context. So you have to find the relationship between the two variables. How can you go from one to the other? I don't know if that helps or not.
It helps. So like if it's like asking for like the mean, like you multiply, well, you're only working with that number, right? Like if they're asking for it. Okay.
Yeah, so like on the previous problem, it was specifically asking you to find the mean of t. So we refer to the mean of x when doing that calculation. On the one that we just did, it was asking you to find the standard deviation of t. So we refer to the standard deviation of x. I think that's what you were saying, right?
Yeah, and then like in our notes, like with all the extra math, we don't have to do that. Like we don't have to.
Nope.
You just multiply it and divide it.
Yep.
Basically. Okay. I think I got it.
We show you essentially like all those formulas so you can understand how we get there, because that's an important part of math, is understanding the process. Because sometimes you need to go back, you need to fall back to the process. because it's entirely possible that maybe you need to start from not knowing the mean or standard deviation of any of your random variables. So you have to start from nothing, build it up. Then once you have some of those things, you can start taking the shortcuts, right, of just multiplying or dividing, adding or subtracting to go from one variable to the other one. But yeah, if you can use a shortcut though, definitely want to use a shortcut. Try to do less math, so to say, if possible. So yeah. Excellent. Thank you for the questions. All right, so then, all right, next part here. And I know we're already 40 minutes in, but I want us to take a look at these next few questions. Again, we're like 15 minutes out from class being over, so I do apologize for going a little bit later than I normally would today. But I want you guys to see these problems, talk about them with your breakout rooms, and see if you have any questions about them. And so what's going to happen is we're going to have 10 minutes to look at the next 3 problems, talk amongst your group on how you could solve them, right? What strategies would you do? How could you find the requested values and answer the questions? Then if we still have time, go to actually answering the questions. But the main purpose is to look at the 3 problems and talk with your group about how you could go about solving them or what you think the solutions would be. All right. So we're going to go like this and like that. So you have access to the next 3 slides. And we're going to start the rooms. If you have questions, let me know. Remember, I'm able to monitor the chats. Okay. Looks like we get everybody back on in here. I think we lost some people along the way. That's all right. So for these problems, I'm going to quickly kind of run through how they can be done. For this first one, making a profit. Here, this works better if I share my screen again. Lots better. All right, so looking at this one, we're doing a linear transformation given by the formula y equals 0.9x minus 0.2. All right, this accounts for the $200,000 fee, right, and 10%, right? If we owe someone 10%, we keep 90%, and then we pay them the 200,000. That means we lost 200,000, right? That's the 0.9, or I'm sorry, the 0.9 and the 0.2 in the formula, right? So we end up with 0.9 times the mean of x, which is 3, minus 0.2. Very nice. Does the calculation for us here. That's kind of nifty. All right, and then for the standard deviation is only affected by multiplying, not by subtracting. So we don't have to consider the minus 0.2 in the standard deviation. We just have to do the 0.9 times 2.52. We get 2.268. All right, so for these 2 calculations, we just need to remember which parts of the calculation affect the mean and the standard deviation. Is there any questions on this problem? All right. So then on the rainy day problem, rainy days, this is understanding the concept here. So we're considering 2 locations and the amount of recorded rainfall. X is the recorded rainfall on this randomly selected date at the airport in Orlando, and then Y is rainfall on that date in Disney World, which is just outside Orlando, right? When we're combining random variables, whether they're dependent or independent, whatever, if we're adding them, we can add their means to get the mean of their sum. Right, so if we're adding x plus y, we can add the mean of x plus the mean of y to get the mean of those combined variables. So yes, it is reasonable. And it's because we can always do that with the means. Now, when it comes to the second question, is it reasonable to take the variance, right, of the total rainfall to be the variance of x plus the variance of y? The answer is no, it is unreasonable. And this is because the events are not independent. All right. Knowing that it rained at the airport in Orlando tells us something about the probability of it raining just outside of Orlando. So the events are not independent. If the events are not independent, we cannot add their variances. All right, and that's from our notes yesterday. We can only add variances with independent random variables. All right. Is there anything else? Is there anything I can further explain on this example? So then on the last one, time and motion. In this example, we're looking at two different tasks that are being timed on a assembly line type work. First one is taking a part from a bin to its position on the chassis. Second is attaching that part to the chassis. Right? These are considered independent events and they are normally distributed. Right? So we could have each of these events represented by a random variable, say x, y, all right? And we want to know what's the distribution for the time required for the entire operations of positioning and attaching randomly selected part, which means we're combining these two normal random variables. When we combine two normal random variables that are independent, we add the means to get the mean of that new random variable. So 20 plus 11 is 31. So the mean of the total time is 31 seconds. To get the standard deviation, we have to first add the variances. So we would have 2 squared, which is the variance of the first process, right? Standard deviation squared, right? 2 squared, plus 4 squared, which would be the variance of the second process. And we get 20. Take the square root of 20, all right? And we get 5 times the square root of 4. I'm sorry, 4 times the square root of 5. I don't know what I was thinking. Anyway, we end up with, what's that number? 4.47 seconds. All right. So in this problem, the best I can come up with, this is, again, a normal distribution. Right, when you add two normal distributions or normal random variables, you get a normal random variable, so it is normally distributed with a mean of 31 seconds and a standard deviation of approximately 4.47 seconds. All right, we would then use this in table A to find the probability that x is less than or equal to 30 seconds. All right. When we do this, we need to standardize the score, right? Which means we take 30 seconds, subtract the mean of 31, divide it by 4.47, right? That gives us a z-score of negative 0.22, right? So this is equal to oh, that's right, because I set that up there. So, sorry, a z. Right. And when we use table A, we end up with a proportion of 0.4129, right, which means there's about a 41% chance of the process taking less than 30 seconds.